right, trig identities, part 2, or we're continuing. Pythagorean trig identity. So, all right, guys, let's focus. So on the last notes 14, we called this equation the Valentine's formula. Cosine squared plus sine squared equals 1. It's not really called the Valentine's formula in real life. It's a Pythagorean trig identity. So cosine squared plus sine squared equals 1. And we realized that we can rewrite this in a certain way to help us out. So you can move the cosine squared to the other side, and you get that. Or you can move the cosine squared to this side, or the sine squared to this side to get that. Now remember, guys, realize, help yourself out with this. 1 minus cosine squared x is also the difference of squares, because 1 times 1 is 1, and cosine times cosine is cosine. So that's the same thing as saying 1 plus cosine x times 1 minus cosine x. And then the same thing can be said with the 1 minus sine squared. 1 minus sine squared x is the difference of squares. So you can write 1 plus sine x, and then 1 minus sine x. And use those whenever they help you out. If they don't help you out, then you don't use them. So yeah, pretty straightforward. What do you guys think? Nothing crazy, right? Same thing with this, guys. 1 plus tan squared equals secant squared. So then you can move the tan squared to the right to get, let's see, if I do that, that's secant squared minus tan squared, which is this guy. You can leave the tan squared alone and move the 1 to the right, and you get this guy. Both of these, bless you squared. Both of these, the secant squared minus tan squared, that's the difference of squares as well, guys. So you can use this. Oh, the square goes over here. You can use this whenever it helps. Or you can use, let's see, this one, secant squared x minus 1. That's the same thing as secant x minus 1, secant x plus 1. Sometimes I put the plus 1 first. Sometimes I put the minus 1 first. It doesn't matter. Nothing crazy. Have I done anything crazy that you do not know? You know this, right? Because you know that, okay. In case you don't understand what I'm saying when I say difference of squares, that's a square, that's a square. I put a minus sign. That's the difference of the squares. So the difference of the squares is a minus b times a plus b. If you distribute this, or if you FOIL this out, you will get a squared minus b squared. Look, a times a squared, a times b plus ab, negative b times a minus ab, negative b times b minus b squared. Notice the middle term zero out, and you just get your a squared minus b squared. So all of this should be tied together. Hopefully all this is just from Algebra 2, and it's making sense. Cool or not cool? Okay, I know, guys. I know that doing math last period is sometimes pretty hard because you're pretty tired. Try and get some sleep if you get a chance tonight, guys, because sleep's important. Same thing with this, difference of squares. I'm not going to continue to talk about it because I don't want to bore you. Let's talk about what's an even, what's an odd function. For those of you taking the SAT this weekend, this question does come out occasionally. An even function is symmetric across the y-axis. It does not have to go through the origin for it to be even. This is an even function. We know that, right? An even function has this property: f of negative x equals f of x. What's an even function? Well, let's see. Cosine looks like this. So cosine's an even function because it's symmetric right on the y-axis. Does that make sense? So cosine x is even. If cosine is even, that means so is its reciprocal. What's the reciprocal of cosine? Not sine. Secant. Secant x is also even. Does that make sense? Nothing crazy, right? Okay. All right. Here we go. Okay. I'll slow down. All right. Let's talk about odd.
Still pause.
Oh.
Stay paused.
You can watch my video. I'm just going to draw a grid. An odd function, a true odd function, because there's odd properties, right? But a true odd function will go through the origin. So an odd function is symmetric about the origin. So odd function is symmetric about the origin. You can rotate it 180 degrees at the origin and it will overlap. So imagine that the origin is like a spindle, and if I had the origin be a spindle, I could go 180 degrees, and this part would overlap this part. Does that make sense? And that's from geometry. You guys don't remember that from geometry? It has this property from geometry. This is a property. F of negative x equals negative f of x. So the sine graph, well, I kind of should have already mentioned it, so well, too bad. The sine graph looks like this. So the sine graph is odd. Sine x is odd. If sine x is odd, so is its reciprocal. Cosecant x is odd. And so is tangent. And it's reciprocal. Let's test it to see if, don't worry, we're not going to write too much when it says if I have a negative argument down here. So let's test it. Let's test this idea of even and odd function. So I'm going to draw a unit circle real quick. And I'm looking at pi over 6 and negative pi over 6. So cosine of pi over 6 is square root of 3 over 2. We know that, right? So we never really finish those unit circle quizzes. I guess we should bring them back. Cosine of negative pi over 6 is also square root of 3 over 2. So notice, I hope that all this is starting to make sense to you. This is where the plus minus comes from when we do arc cosine. Look, the positive pi over 6 is square root of 3 over 2. The negative pi over 6 is also square root of 3 over 2. Here's the positive pi over 6 for you visual learners. Square root of 3 over 2, comma 1/2. Here's the negative pi over 6 for you visual learners. Square root of 3 over 2, comma negative half. Cool or not cool? Now let's test the sine, because the sine we said was an odd function. Well, sine of pi over 6 is a half. So sine of negative pi over 6, notice it's a negative half. OMG. So for sine, so Chav, what are you saying? So if you ever have sine of negative theta, you can say that's just the same thing as negative sine theta. If you ever have cosine of negative theta, that's just the same thing as cosine of theta. Yay or nay? Does that make sense? Okay, I tried putting the ideas together. All right, and then it says here, what about sine, cosine, and tangent, etc. are squared and I have negative argument? So by argument, guys, I mean what's inside the sine, cosine, and tangent. So I know for this one, it's not a big deal. So if you have cosine squared of negative theta, well, you already know cosine's even anyway. So if I square it, no big deal. Whatever's negative just, turns positive. So this is not a big deal. I don't think no one's shocked by that. But for this one, for sine, even though we said it's odd, if it's a negative argument, it's going to be the same as if I had a positive argument. Child, but why? I want to know why. Okay, I'm going to use the same example. If I said sine, I'm going to use pi over 6 first, because that's what I used over here. Sine squared of pi over 6. Well, that means, what does that mean? That means that 1/2 is squared, and if I square it, that's 1 over 4. You guys see that? All right, so now let's see what this means if I put a negative pi over 6. Sine squared of negative pi over 6. And I'm going to slow down. Notice on the side, I wrote that sine of negative pi over 6 was what? Negative half. So that means I put a negative half on the inside, and I'm squaring it. When I square that negative half, do you get the same value as 1/4? Yes. So when you square it, you don't care about the negative argument. So what I'm trying to say is this. Sine squared of negative theta is exactly the same as sine squared of theta. But Chav, you told me it was odd. Yes, you're right. Sine is odd, but I'm squaring it, and negative times a negative is a positive. So that's why I don't care about the negative argument, as long as it's still a theta. As long as the number is still, the magnitude of the value is still the same. Cool or not cool? ¿Cómo te sientes? How do you sit? No, ¿Cómo te sientes means how do you feel or how do you sit, depending on the context, right? Okay, right? I know that much Spanish, I think. Okay. I know, guys. I know it's hard to do math last period, especially when you're already tired. All right. What identities should you know cold? Stone cold. If you know one identity, did you guys talk to your parents about sine squared plus cosine squared equals 1 or your guardians? Oh, you guys didn't. You should tell them, guys. If you know one thing and one thing only from all week, it's this one thing. Cosine squared theta plus sine squared theta equals 1. Know that one. Know it, know it, know it. Cool or not cool? Okay. Next, what else should you know cold? Well, I know that cosine and sine repeat every 2 pi. So if I have a theta plus 2 pi, that's the same thing as just saying cosine theta. Because it repeats every 2 pi. Same thing for sine. Sine of theta plus 2 pi is the same thing as just sine theta. Don't believe me? Let me take my little calculator out and watch. I just want to show you. I just want to show you really, really fast. Apps. Come on, buddy. Okay. I can quit. Oh, look, there it is. Oh, I accidentally erased it. Okay. Cosine pi over 6 is this value. Check it out what happens when I write cosine pi over 6 plus 2 pi. OMG, it's the same value. Because you're just doing one revolution. You're back in the same location. Does that make sense, guys? Okay, perfect. Same thing with sine, guys. All right. What else? Tangent. Tangent repeats every pi. And I know we haven't graphed tangent. It's not because we don't like tangent. It's not because tangent is like the ugly duckling or something. It's just we just haven't graphed it recently for some reason. We'll start graphing it soon, so we have experience with it. Tangent theta is the same thing as tangent theta plus pi because it repeats every pi. Yeah. Okay. So if you know those codes, then I think you'll be okay. Cool or not cool? Let's see. We already know about even and odd. It would be nice if you know that sine negative theta equals negative sine theta. It would be nice if you knew that cosine theta is the same thing as cosine negative theta because of the even odd properties. And then of course the square ones that we just talked about over here. But yeah. Okay. Cosine and sine differ by a phase shift of pi over 2. Chav, what do you mean? What do you mean? Okay, here is sine. It's not perfect, but there it is. And here is cosine. If I move cosine pi over 2 to the right, it will look exactly like sine. If I move sine, if I move the sky blue curve pi over 2 to the left, it will look exactly like cosine. Do you see that? Yeah, let me see if I can copy and paste. Let me see. Yay. Okay, look, check it out. I'm going to move it pi over 2 to the left. Oh, I can't tell. It looks exactly like cosine. It continues, right? But still. Do you see what I mean? Okay. So, I guess maybe I should have moved the cosine pi over 2 to the right. Cosine pi over 2 to the right. Boom. Oh, now it's sine. Oh, well, sorry. I mean, I guess if I cut it, but yeah, you know what I mean. See? So what does that mean? That means this. That means that I can represent cosine as a sine with a pi over 2 shifted, but usually they do it like this. And I know it's a little funny, but I'll show you that they're the same. Like, Chav, I'm used to seeing theta minus pi over 2 because in algebra I did x minus whatever. Okay, relax. It's the same, guys. And then sine theta, and I'll show you to make you a believer, is cosine of pi over 2 minus theta. They can be interchanged. So I'm going to take my calculator, and don't worry, guys, I'll come back to this. So check it out. I already have it here. As a matter of fact, I have y3 and y4. See how y3 is sine x and y4 is cosine pi over 2 minus x? y3 is black, y4 is purple. Let's push graph. Oh, I guess let's draw it from the beginning. So let me turn off Y3 and Y4 and turn on Y1 and Y2. All right, here we go. Y1, how do you turn it off and on? Just push the equal sign, push enter, push enter. I'm going to start making little snippet videos of how to use the calculator. Would you guys like that stuff or no? Okay, so there's cosine x, there's sine pi over 2 minus x. I'm going to push graph. Look, there's cosine x in blue. And then look, there's sine of pi over 2 minus x in red. Cool, right? All right, I'm going to go back to my y equals. I'm going to turn it off by pushing enter on the equal sign. And then I'm just going to turn the y3 and y4 on by pushing enter on the equal sign. And now the y3 is in black and the y4 is in pink. Yeah, I love this calculator. If I were you, if you have a TI-84, I would just carry it with you at all times. Put it in your pocket like your phone, you know? Okay, anyways. So yeah, there it is. Cool, right, guys? Or not cool? Yeah, cool. So now you know that this is definitive. It's true all the time. Okay, I think that is all you need to know. And now you are pros at solving trig expressions, at transforming them. Relax, you'll see what I mean. So look, check it out. Question 1. It says, which of the following is equivalent to sine negative theta over cosine negative theta? Well, I know that sine is odd. And I know that cosine is even. And then, we're not teaching to the test, but I noticed that most of the arguments but one, there's only one letter E has a negative argument, but the others do not. So then I'm thinking maybe my argument should be positive. When I say argument, I'm talking about the theta, what's inside the parenthesis. So if I use my properties about sine and cosine, I can rewrite this as saying negative sine theta, because that's what I said earlier in page 1, right? That's what I said. Where are you? Right. I said it here that sine x is odd, and then look, here it is in purple or sky blue, no, it's purple. Sine negative theta is negative sine theta. So there it is. And then divided by cosine is even, so I can write cosine what? Theta. What's up, miss?
Miss Kilgore needs her calculus.
Nah, tell Kilgore to forget it. No, they're in the back. Sorry, miss. All right. So, negative sine theta over cosine theta. I don't see that answer in there, but it is in there. Sine over cosine is the same thing as what? Not cotangent or tangent? Which one? Tangent. No, it's all good. It's all good. This is a safe space. Tangent. Tangent, negative tangent of theta. Is that answer in there? There it is. Cool or not cool? Okay. E, or D, sorry. Bless you squared, bless you cubed. Okay. Next question. All right, here we go. Ready, guys? Focus, guys. Focus. So at first glance, you're looking at it and you're like, cosine squared over 1 plus sine theta. How do I do this? Here's what you should tell yourself. You could, there's other ways. You could multiply this by 1 minus sine over 1 minus sine the conjugate. You could. But why do you, I don't know, maybe that's easier for you guys, but, all right, guys, focus. In your brain, here's what should be going on. Here's your thought process. You see something that's squared, and in your head, you should be going, I know something about cosine squared. I know that cosine squared theta plus sine squared theta equals what? Equals 1. You know that much. Yes or no? Yes. I know that I can get cosine squared by itself by moving the sine squared to the right. So now I'm writing cosine squared theta equals 1 minus sine squared theta. Do you guys see that? So I'll put this as a side note. Because I know that, I'm going to substitute cosine squared theta for 1 minus sine squared. So I'm going to write 1 minus sine squared theta over 1 plus sine. So catch up to here. Right. Here's your thought process. When you get to here, you're looking at it and you're like, I don't know what to do next. And then you remember, like, well, Chavez did say something about that's kind of like the difference of squares. Look, I have it right here, the second line. That's the difference of squares. And hopefully that rings a bell, something in here. And you're like, wait a minute, I see a factor of 1 plus sign in the bottom. OMG. And then you come in here and you write an equal sign and you're like, well, that's the difference of squares. 1 plus sine theta, 1 minus sine theta, all over 1 plus sine theta. And then you come to the realization that you can cancel out a common factor. What factor can you cancel out? The 1 plus sine theta, you can cancel them out because it is like a product. And this is that line there is like dividing, right? Dividing by that same one of the factors that's the same. So you can just cancel those suckers out. And what do you have left? 1 minus sine theta. And then I look for that, and OMG, there it is. How do we feel? Is this getting easier, guys? Yeah. If not that bad, you just got to go slow, and you just got to go through the process. Trust the process. All right. Let's go to the next question. It looks hard. Relax. It isn't. It just looks tough. You look at it and you're like, none of these here, look at your answer choices. None of them have a plus 2 pi in it. So your thought process should be, well, maybe I have to get rid of those 2 pi's. What did we just say earlier about cosine x plus 2 pi? It's the same thing as just cosine x. So I'm going to write cosine x over sine x plus, and then sine x plus 2 pi, that's the same thing as what? Sine x all over cosine x. So catch up to there. And then you get to there and you're like, well, I don't see that answer in there. I probably have to add these two suckers up somehow. So we're going to do something called the common denominator. I'm going to multiply the left term by what over what? Yeah, cosine over cosine, sorry. Cosine x over cosine x. And I'm going to multiply the right term by sine x over sine x. Make sure you put sine x over sine x because that's a 1. If you just put 1 sine x, it's not equivalent. Don't do that. All right, cosine times cosine. So I write cosine squared over cosine x sine x plus sine times sine. Sine squared over cosine x sine x. Are my denominators, well, I'll slow down so you guys can catch up. Are my denominators the same? Yes, so I can just write it as one term, cosine squared x plus sine squared x all over cosine x sine x. Catch up to here. And then hopefully something's going on in your brain that says, I see Valentine's formula again. Cosine squared plus sine squared equals what? Equals 1. And now you get to this statement and you're asking yourself, well, I don't see that answer in there. That's not what I got. Like, I don't have any of those answer choices. You have it in there. I can expand this into 1 over cosine x times 1 over sine x. Do you guys see that? What is 1 over cosine? Secant. What is 1 over sine? Cosecant. So let me circle them. This is a secant x. This is a cosecant x. So secant x, cosecant x. Is that answer in there? Yes. C. Ah, funny. Bilingual. C, yes. Okay. All right. Guys, this is about as hard as it gets. It will not get harder than this question. We're going to go slow. Don't worry. Oh, yeah, this comes out on the SAT, but they always give you easy ones. It's never. Yeah, do you guys remember these on the SAT? No, they are, but the simple basic ones. 1 over sine times blah, blah, blah. Yeah, tell me if you see one on Saturday. Don't tell me the question. Just like, oh, yeah, we bumped into one. All right. Oh, you know what? They might not have them anymore. There used to be... Well, they used to be something called subject exams.
Oh, they don't have subject.
And they don't have them anymore. They took them out like 2 or 3 years ago. I don't know why. That we were killing it because of the... Okay, I'll stop talking before. All right. Here we go. No, you if you had like... We were killing it. Like the few that took it, like it was all just... Okay, anyways. All right, here we go, guys. Ready? How do you tackle this? When you look at these expressions, here's what you should go through your mind. You should be like, oh my God, I'm scared. I don't know how to do any of this. I'm focusing on this one first. Yeah, why? Why am I focusing on that first? Because there's something that I haven't seen yet. Well, that we haven't seen yet. What do you notice that we haven't seen yet? The cubed. We have nothing. We have no tools right now for anything cubed at the moment. Correct? So you're going to rewrite it into something that you do know. So I'm going to rewrite it. So here I am rewriting it. Let me put everything in sky blue for this. If you have colored pencils, here's a good one to put colored pencils. I'm going to write 1 plus sine theta on the top. And I'm going to rewrite the bottom. I don't know anything about cubes, so I'm going to rewrite this as cosine squared times cosine theta. Is that cosine cubed?
Yes.
Yes. It's like x squared times x, guys. X squared times x is x cubed. So it's the same idea. Cosine squared times cosine is cosine cubed. Are we okay? Now this I do know something about. So here's your thought process. You see a 1 plus sine theta on the top, and you're like, I know that cosine squared is 1 minus sine squared, and I think that I can do something with that. So I'm going to go to the side. I'm going to put side note, and I'm going to write cosine squared theta plus sine squared theta equals 1. So I'm going to write cosine squared theta equals 1 minus sine squared theta. That's what I'm going to substitute in for this one. So here's my 1 plus sine theta on the top. And on the bottom, I'm going to write parenthesis 1 minus sine squared theta. Make sure to put it in parentheses times cosine theta. Yeah, you'll see right now.
Okay.
1 minus sine theta is the difference of squares. Can I expand that? Yes. So now I'm going to write 1 plus sine theta. That's from the top, from the numerator. Over, and I'm going to write it like this. 1 plus sine theta times 1 minus sine theta times cosine theta. Because I have a product in the denominator, something times something times something, over 1 plus sine theta, can I cancel out the 1 plus sine thetas? Yes, cancel it out. Bam, bam. So now look what I have. This is, you have nothing in the top, so write 1, the number 1, because that's still a numerator. And on the bottom, I have 1 minus sine theta, and then cosine theta. Now I'm going to bring it back, and I'm going to bring this back. I'm going to put it over here. So here we go. I have secant theta over 1 minus sine theta minus what? 1 over 1 minus sine theta cosine theta. So catch up to here, guys. Has all this made sense so far? Okay, here's what you ask yourself. Once you get to here, you say, okay, I'm going to subtract these. I already noticed that I have a 1 minus sine theta here. This one has a 1 minus sine theta. The only thing that's missing on the left that doesn't look like the right is a what? Cosine theta. So if I want to get a common denominator, if I want to subtract them, I need to get a common denominator, which that means I'm just going to multiply just this one, this left term, by what over what? Cos over cos. So now when I do that, here's what I have. I have cosine theta secant theta over, and I'm going to write it just like that one, 1 minus sine theta times cosine theta minus 1 over 1 minus sine theta cosine theta. And I'll wait for you guys to catch up. My denominators are now the same. So can I combine them? These two fractions? Yes, I can. So I'm going to write cosine theta secant theta minus 1 over 1 minus sine theta times cosine theta. So catch up to here. Oh, sorry about that, guys. We're almost done, guys. We're almost done. We're so close. Okay. All there is now to do is to evaluate the numerator. And this question kind of got me sad this morning because I thought it was going to be more exciting. Do you see how you have cosine theta times secant theta? That is the reciprocal of itself. Cosine and secant are reciprocals of each other. Cosine and secant are reciprocals of each other. So anytime you multiply by your reciprocal, you just get 1. You can write it cosine theta times 1 over cosine if you want, but that's just 1. So I have this in the numerator, 1 minus 1 over 1 minus sine theta cosine theta. What's 1 minus 1? 0 over 1 minus sine theta cosine theta. What's 0 divided by anything? 0. Yes.
So, can you scroll up real quick? When you subtracted it from what, like minus 1 over 1 minus sine theta cosine theta.
In this line?
Yeah.
Okay.
Couldn't you just, like from earlier, just do secant theta over 1 minus sine theta?
Yeah. If you were, yeah, I just didn't want to talk about it because I didn't want to confuse anyone. If you recognize this, guys, you don't have to, but if you recognize this, you see how you have 1 over, let me write it better. You see how you have 1 over cosine theta right there? That's secant theta. You could have done just, this is the first one, secant theta over 1 minus sine theta minus secant theta over 1 minus sine theta. And then you would have realized I got something that's the same as the other thing, and something minus the same thing is just going to be 0. Yeah, it doesn't matter how you do it. There's many different avenues. Oh, the number one mistake that I see, and I see you guys do it all the time. So perfect, because right now it's SAT. Okay. Write this down, but not yet. Oh, I guess write it down. A plus B plus C divided by AB. Can I cancel the A? Or can I cancel the B? Or can I cancel both? No. But I see it all the time. You guys will do cosine x plus sine x divided by cosine x. And I'll see you guys go bam, bam. Don't do that. The only time you can cancel is if you have a product and you're dividing, because product and division are inverse operations. So now this will cancel like that. It's like saying 3 plus 4 divided by 3, and some of you are like, oh, cancel. That's 4. Like, no, guys, 4 plus 3, 4, 5, 6, 7. 7 divided by 3 is not 4. See, but 3 times 4 divided by 3, yeah, that's 4. 3 times 4 is 12. 12 divided by 3 is back to 4. Do you see the difference? Cool or not cool? Okay. All right, guys. Now, you might have heard, I don't know, did you guys already hear? No? Yes? Okay. I'll tell you guys in case you didn't hear. You might have heard, I do want an attempt for Trig Identities 1. So I guess let me tell you guys the reason first why I'm doing what I'm doing. Traditionally, every class is different, so I can't compare you guys to last year's class or the year before. But traditionally, Trig Identities 1, usually groups do really well, like really good. So here's what I'm going to do to help you guys out. I'm going to count this as the test grade. There's only 12 questions on the quiz, so maybe that's also part of the reason why you guys do really good on this. There's only 12 questions. They're all very similar to this. I'm going to count it as the test grade. I do want an attempt today, and I'm going to put the grade in on Friday, and I want you guys to ask me questions on what you're getting wrong. Don't ask me while you're live. You can help each other out. It's not a big deal to me, but make sure that you're understanding why. And I'm gonna pick it up on Tuesday next. I'm gonna pick it up December 4th. All right, guys, a warning. I know some of you may be using software or some apps to figure out some of the answers. Guys, it's hurting you in the long run. Maybe it's helping you short term because you're getting 100 on something. But guys, your semester exam is going to have these questions. And in order to get full credit, just like your other exams, I need to see justified work. So help yourself out and make sure you understand. You can take it as many times as you want, guys. I don't put a restriction. Next year for calculus, I'm going to put a restriction of 20 attempts. But right now, notice it says take it as many times as you want. Don't worry, you don't need 20 attempts. I think the most I've ever seen someone is take it 16 times for next year if you take calculus. But notice, guys, there's no restriction. You can take it as many times as you want. So be honest. Am I clear with that, guys? Okay. All right, guys, we have an hour. We have 55 minutes. That's enough to do at least one attempt. So let's get one attempt done. Good job, guys. I'll see you guys later.